Hello and welcome back to Summer Work Help for Calculus 1. On this video, we're going to be taking a look at question 2. The directions here say simplify. Final answers should not include, negative exponents or decimals. So I'm going to try zooming in on each problem as opposed to question number 1. We'll see. I think this might work a little bit better. So 2a. So you want to simplify. And in general, when you see the word simplify, more often than not, that means no parentheses. Now, exceptions can be made depending on the problem, right? But for a question like 2a, when it says simplify, it basically just means distribute, right? So this question is kind of reintroducing the distributive property. Just as a reminder, the distributive property basically just says that we're going to take that 2x and we're going to multiply it to both terms inside the parentheses. So my first term is 2x times x squared. Well, I multiply my coefficients. There's an invisible 1 right there, right? We don't write the 1, but it is there. So my coefficient on my first term is 2 times 1, which is 2. And then I have x times x squared. Well, as we saw in question 1, when you multiply with the same base, you add your exponents, and there's, again, an invisible 1 right there. So what I have is I have x to the 1 plus 2, which is 3. So again, when you multiply, you add your exponents. And then I have 2 times negative 7, which is minus 14. And then I have essentially x to the first times, you could think of it as like almost like x to the 0, but don't make it more complicated. It's just a single x. So when you distribute 2x to both terms, you end up getting 2x cubed minus 14x. And that is as simple as we can make that expression. Notice that when we apply the distributive property like this, we're basically doing the reverse of factoring, right? A different question may have given you, what ultimately was our answer, and then said to factor, and then that would mean kind of going in reverse and getting what we started with as your final answer. So distributing and factoring are essentially like inverse operations. So final answer for 2a. 2x cubed minus 14x. 2b. Again, we want to distribute. So what I have here is we have a binomial squared. So 3x plus 8. And if I'm teaching this class, or if I'm teaching your class, I'm going to say throughout the year, don't make this mistake. Do not just jump right to this. Sorry, squared. Okay. So please don't do that. Okay, that is wrong. You cannot just distribute the squared to both terms and call it a day. So when you have a binomial squared like this, I recommend, especially if you're, I don't know, if you forgot how to do this or you struggle with it or whatever. If you find this topic a little challenging, I would encourage you to actually write out what this looks like. Right, we have 3x plus 8 squared. Well, when you square something, it means you multiply it by itself. So when you have quantity 3x plus 8, close parentheses squared, it means you take the 3x plus 8 and you multiply it by another 3x plus 8. Notice the sets of parentheses here. That's very important. And now I think a lot of you, hopefully, can recognize that what we have is we have two binomials that are getting multiplied together. And in order to distribute here, we're going to use FOIL. So first, outer, inner, last. F-O-I-L. First, outer, inner, and last. I think a number of you are familiar with this. So first, we multiply by the first term in each binomial. So that's 3x times 3x. So 3 times 3 is 9, and x times x is x squared. That's our first term. Our second term is the outer terms. So it's sort of the terms that are sort of like on the outside like that, right? So that means we're going to multiply this 3x by this 8. So 3 times 8 is 24. And then we just have a single x. So it just kind of comes along for the ride. So that's my outer. Doesn't seem to want to erase the highlighting here. Okay. Inner means we multiply by the terms that are on the like sort of the inside. So that's going to be this 8 and this 3x. Well, again, 8 times 3 is 24, and we still have a single x. So we get another 24x. That's not a coincidence. And then for the L in FOIL, it's last. So it's my last two terms. So in this case, that's 8 and 8. And when I multiply those together, I get 64. All right. We are almost done this problem, but we are not quite done because I want to combine like terms. Certainly in a class like calculus, the expectation is that you will be doing relatively straightforward simplifications like this, of combining like terms. So 9x squared, that's my only squared term, so that's just going to kind of do its own thing. And then I've got 24x plus another 24x. Well, if I have 24 of something and then I have another 24 of something, I have 24 plus 24, which is 48 of that something. So 24x plus another 24x gives me a total of 48x. And then 64 is my only constant here. And so that is my final answer for 2B. Just a relatively straightforward application of FOIL. But again, notice that you cannot just distribute the squared to both the 3x and the 8. If you do that, you will be missing the 48x term. You'll be missing that sort of that middle term. And it's a common mistake, but just don't be the one to make that mistake, right? Let one of your peers make that mistake, but you're on the ball here. This should be C. That's a typo. So for 2C, we have a quotient. We have a fraction here. And there's a couple ways that you can kind of think about this problem. I'm going to kind of assume with these videos that maybe there's some students that are kind of struggling with this. If you can answer this question and get essentially the final answer quicker than the way I'm about to show you, then great. Right? I might show you some steps that you might think are not necessary, and that's fine. You don't have to do sort of all the intermediate work. As long as you kind of get to the right answer, you're probably fine, because you probably did not, if you got the right answer, you probably did not like luck into the correct answer. But I'm just going to kind of show you how we can really sort of take this problem apart and make sure that we understand what's happening here. So we have 25 and we have 15. So those are sort of our coefficients on each term, on the numerator and the denominator. I want to sort of ask myself, well, what factors in both the 25 and the 15, what can I cancel, right? What's the GCF? What's the greatest common factor between 25 and 15? The greatest common factor between 25 and 15 is 5. Because 5 goes into 25 5 times, and 5 goes into 15 3 times. So again, you don't have to actually write out this step, but I'm going to write out the 25 as 5 times 3, and I'm going to write out the 15, oh sorry, 25 is 5 times 5. So 25 is 5 times 5, and the 15 is 5 times 3. And then what I have is I have 8 x's in my numerator, and I have 14 x's in my denominator. I have 6 y's in my numerator, and I have 2 y's in my denominator. These 5's cancel. Then notice I have 8 x's in my numerator, and I have 14 x's in my denominator. So what's going to happen is essentially all 8 of these x's are going to go away, because they're going to cancel out 8 of the x's that are in the denominator. So there were 14, and now there are 6. Because of the 14, 8 of those x's canceled with the 8 x's that are in the numerator. So in the numerator, all of your x's are gone. And in the denominator, of the original 14, you've got 6 left. And then likewise with the y's, in my numerator I've got 6 y's, and in my denominator I've got 2 y's. So all 2 of those y's are going to go away in the denominator, and then in my numerator of the 6, 2 are going to cancel. I'm going to be left with 4. So now I'm just going to write what's left. In my numerator, I have a 5. All of my x's are gone, and then I have y to the 4th over. I have a 3. I have 6 x's remaining in the denominator, and all of my y's in the numerator have gone away. And so this is as simple as I can make my original expression. Now, like I said, if you can go directly from the original problem to the final answer, I can't imagine anyone having a problem with that. As long as you you get there, right? You got to sort of understand how we got there. So final answer for 1C is 5 y to the 4th over 3 x to the 6th. All right, and then the last part of question number 2. We have quantity 2x to the 0 power times quantity 3x cubed to the 2nd power times quantity 5x to the 5th to the -1 power. All right. So what I'm going to do, I guess there's maybe a couple different ways that you can do this problem. I'll just show you the way that I would solve this. So for each of these these 3 terms that are being raised to a power, well, I have 2x, and the 2x is being raised to the 0 power. Now, I guess we didn't really say this, but I'm just going to go ahead and make kind of an executive decision here. We're going to go ahead and assume that x does not equal 0. All right, the problem did not say that, but I'm gonna say it's okay for us in this problem to just, for now, just assume that x does not equal 0. If x does not equal 0, then I have basically something raised to the 0 power. So this is going to simplify to, oop, that's not what I want. Let me fix that for a second. Okay. So what I have here is I have something to the 0 power, which simplifies to just 1. Because I'm just making a decision here that x does not equal 0. Times. Now I have something that's being raised to a power. I have a product that's raised to a power. And as we saw in question 1, when you have a product that's raised to a power, you can raise each individual thing to that power. So the 2 distributes to both the 3 and the x cubed. So I have 3 squared, which is 9. And then I have x cubed that is raised to the 2nd power. So I have a power to a power. When you have a power to a power, again, as we saw in question 1, you multiply your exponents. So this term simplifies to x to the 6th. Okay, times. Now I have something that is being raised to the -1 power. Well, again, as we saw in question 1, when you have a negative exponent, it basically means that you if it's in the numerator, which it currently is, it moves into the denominator. Like that. Now, if you wanted to, you could write this as to the 1st power, right? Because the -1 becomes a +1. But hopefully you recognize that raising something to the 1st power doesn't really change it. So I would encourage you to just drop the 1 at this point and just write it like this. If writing the 1 sort of helps you, then knock yourself out. But for me, I think that including fewer symbols just tends to simplify the process. All right, so this is just kind of one big product. So we just kind of multiply everything. Multiplying by 1 doesn't change anything. So that first term is kind of meaningless. And then I've got 9x to the 6th times 1 over 5x to the 5th. So this 9x to the 6th is over 1. And so we're essentially multiplying fractions here. So I have 9x to the 6th times 1, which is just 9x to the 6th. And then in my denominator, I have 1 times 5x to the 5th, which gives me this. We are almost done. We've got a 9 and a 5. And again, just like part C, I want to ask myself, all right, well, what's the GCF of 9 and 5? Well, the GCF of 9 and 5, they're what are called mutually prime, in that they don't really have any factors in common other than 1. 5 is prime, just straight up prime, and 9 you can only rewrite it as 3 times 3, and 3 doesn't go into 5. So those not the 9 and the 5 is going to stay, and then I have 6 x's in my numerator, and I have 5 x's in my denominator. So all 5 of those are going to go away, and of the 6, only a single x is going to remain in my numerator. So what I have is I have 9x. Now it is x to the first, but you want to express your answers like as simple as possible. And if it's x to the first, don't write the 1. Just leave it as x. Just leave it as x, right? You can assume it's x to the first. So it's 9x over 5, and that is my final answer for 2D. So I'll go ahead and zoom out just so we can kind of see all of our final answers here. But that is our final answer those are our final answers for question 2.